In this section, I want to talk more about interfaces. Now, interfaces were added to Java as partly a way to get around the restriction in Java that you can only have single inheritance. A class can only have a single parent. If you have abstract classes and you want to extend an abstract class, well, you're done. You can't extend more than one class. And there's no other mechanism available for saying a class is a kind of two other things. Interfaces were added to Java to allow you to say is a kind of with multiple classes. Now, when you try to picture what interfaces are about, sometimes the easiest way that I think about it is to think of a class as an object in space. Think of it as looking at, say, a cube or something like that. And when you're looking at the cube head-on, that's the class. That's all the methods available in the class. That is the type of object. That's the thing you instantiated. If you look at it from above or from below, depending on your perspective, that's a superclass or a subclass. That's looking at what the parent can do or what the child can do. And of course, the child can do everything the parent can do and more. So that's the inheritance relationship right there. An interface would be like looking at this class from the side. Say, yes, it is a nice class, but it also has the following features, and we can look at it exclusively from that perspective. In this section, I want to demonstrate one feature of that, and then I'll show other features in other sections as well. So in this case, leaving the employees for a moment, I want to talk about a task class. And the reason I'm using a task here instead of employees is I have multiple additional attributes here so that I can do various sorting mechanisms with lots of different features. So a task has an ID and a name. I've got a start date and an end date, which I initialized to now so that they're not null. I have a priority and a Boolean to say whether they're completed or not. The rest of this class is simply constructors, getters and setters of various types, a toString method, an equals method, and a hashcode method. We'll look at in a later section at how you generate equals and hashcode methods and what they mean. But in this case, just think of a task as a collection of these following properties that we just saw. And I want to do some various sorting algorithms based on this, or sorting. I want to sort these tasks based on some of these properties. So I made a class called taskSorter, and I put some tasks in an array list, and all I varied were the IDs and the names and the priorities. That's the other thing I'm setting here. I'm not going to worry about the dates for the moment or whether they're completed or not. I will come back to that a little bit later. These tasks may look vaguely familiar if you've ever seen Monty Python and the Holy Grail. And let's be honest, if you've never seen Monty Python and the Holy Grail, you're not really a developer. On the other hand, if you've never seen it, then you have a real treat in front of you, so at least there's that. So at any rate, I made an array list and I added these tasks to it. And now I can simply print them just to show what they look like. I can use my traditional for each loop. I'll say for each task, t in tasks. Let's do a print of t, and when I run this, you see that it's using the toString method that I generated, which just shows the values of all of the properties, but that what I'm getting as an output is the so-called insertion order, the order that the tasks were added to the array list. That's the same order I'm printing them out. Now this, by the way, is an example of what the code would look like in Java 7 or below. My IDE is saying, by the way, you know you can replace this with the new for each method using the method reference on println. We're going to talk about this in a moment. This is, again, the new method that has been added to iterable as a default method, but at least I'm able to print them this way. But none of that has anything to do with interfaces. Where do the interfaces come in? I want to sort these tasks by various properties. In order to sort tasks, you have to use, in Java 7 or below, a class called collections with an S. Collections has a sort method that takes a list. And I can put my tasks into that list. And what I'll see here is I'm already in trouble. And the reason I'm in trouble is that the task must implement the comparable interface. And they're not implementing the comparable interface at the moment. Now, what's that all about? Whenever you want to sort a list or a collection of any kind, the idea is that you have to take all of the elements two at a time and compare them and decide whether one is less than, greater than, or equal to the other. And based on that measurement of each pair, then the algorithm decides to move things around. And there's lots and lots of sorting algorithms out there. Right now I'm just trying to use the default sorting algorithm built into Java in the sort method, which is basically a modified merge sort. Again, the details of the algorithm aren't that important. What's important is that I have to do this comparison mechanism. Now this is where the interface comes in. Because when you're writing the algorithm for sorting, you don't want to say, well, I'm going to write a sorting algorithm for strings, and then I'll write a separate sorting algorithm for employees, and yet another sorting algorithm for tasks. I want to be able to sort anything. And how am I going to do that? Now, I could say, well, what if I did a sort for some parent class that had my method in there that I needed? In this case, it's called compare to. But the problem is, remember, we only get one parent class. And if you've already extended one class, then you can't extend another. So that it's not practical to introduce a superclass just for sorting, because then I would restrict my inheritance tree to the point of unusability. So instead, they've added interfaces. And if I take a look at the interface called list here, you see this is the, well, this is just the list. I'm going to come back to this one. What I want to look at now is collections with an S. And I can go to that one. And collections has the sort method. If I scroll down to the sort method here, and you see the sort method sorts the specified list in ascending order according to the natural ordering of its elements. What does that mean? That means that my elements must all implement the comparable interface. Now, if I look at the interface called comparable, it says I have one method called compare to. It takes the generic argument, whatever it is I'm comparing, and it returns an integer. And the integer that is returned is either negative, 0, or positive. And if it's negative, then the object I'm comparing to is, well, I'm less than the object I'm comparing to. If we return 0, then they're equal. And if I'm greater than the object I'm comparing to, then the integer is positive. They also stress in the contract that you should make it so that the equals method is consistent with this. In other words, if two objects are equal by the equals method, they also should return 0 on the compare to method. So right now, of course, I don't have comparable here, and this is actually not a compilation error at the moment, it's an IDE error. If I try to run this, it's going to give me errors saying, wait a minute, there's no suitable method sort for task, because they actually want something that implements comparable. So let me go back to my task class and implement. Now I got to make sure I get the right one. I want comparable, not comparator. I'll show that later. And this will be comparable of task right here. And what it's complaining about is that I don't have the proper method implemented. So what I do now is, let's find a nice empty space here. And I'll say I need to implement my unimplemented methods here. So if I just say implement methods, there's my compare to method. And this is the method that will provide the measure, the sign, depending on whether I'm greater than, less than, or equal to the other. So the argument is of type task. I want to return an integer. I have all these properties to sort on. What's going to be the natural sorting? Let's just make it alphabetical just in order to have something to sort by. So what I want to return is the name of the current object, and I will compare that to, let's change task O here to task, and I'll say task.name here. And what I've basically done is I've delegated my task comparison to a name comparison. And the name comparison is going to be alphabetical. Now that's not strictly true. It's actually lexicographical, meaning the capital letters will come before the lowercase letters, but it's essentially alphabetical. Now that I have that, when I run my sort, everything will work. The only problem is I'm not going to see any output or after the sort has happened, because the collections.sort method returns void. Now later, when we return to this, we'll talk about how when we use Java 8 streams, there's a sorted method on stream that will produce a new sorted stream. But right now, I'm just trying to emphasize the interface part of this. But if I look at the documentation for sort, you will see here that sort takes a list as an argument and returns void. So if I then want to print them again, probably best if I just copy and paste here. And then let me put in a print here to say after the natural sort, like this. And now when I run it, you see that the names are now in alphabetical order. A, D, G, L, and R. And the tasks, the IDs are now mixed up and the priorities are all mixed up and everything. But we did manage to sort them alphabetically. So this is a mechanism used with interfaces. They were able to implement the algorithm in terms of the interface type, and the beauty, of course, is that a Java class can implement as many interfaces as you want. You can always add in another interface. And by implementing the sorting algorithm in terms of the comparable interface, I can always add that implementation to my class without affecting the rest of the inheritance hierarchy. Now, the next step, of course, would be to try to deal with classes that I cannot modify, and then I'm going to need the comparator interface instead of the comparable interface. And when we talk about inner classes, I'll come back to that one in a lot of detail. But right now, I simply wanted to show this mechanism for interfaces and how they can be very useful. In the next section, I want to talk a bit more about these default methods in interfaces and static methods in interfaces and how they can be helpful.